Hello, in this video we are going to do some very tricky trigonometric identities, and these are the identities that you could see in most trigonometry books, and I feel like these are ones that are normally covered beyond the scope of class, and also they have a couple of really innovative ways to solve them. Now, we have three basic ideas of how to solve a trigonometric identity. The first thing you should do is try to break everything down in terms of sine and cosine. Then maybe, if it helps, to make everything into one kind of trigonometric identity. So if you have a sine squared and a cosine squared, it's possible to turn those all into one kind of trigonometric identity, such as cosine or sine, depending on what you're looking for. In the third step or strategy is to always seek the answer for guidance. And that last strategy, to seek the answer for guidance, is a little nebulous and it doesn't really give you a straightforward direction, but it's kind of like watching your opponent while you play a game of chess. Always look to see what your opponent's doing so you know what to do next. So for our first example here, and this is probably going to be a two-part video since I've got several examples I'd like to do, and this is pretty much starting off with the easier or earlier questions I got from students. We're going to start off with 1 plus cotangent, or sorry, 1 plus tangent. I was looking at the answer for a second. 1 plus tangent theta divided by 1 minus tangent theta. And we want to know how is that going to be equal to our desired answer, which is going to be cotangent plus 1. I should put a theta in there. And cotangent theta minus 1. Now, I will stress that there is more than one way to do this problem. Your way may not be the same as my way, maybe actually faster or slower, but it's still can reign true. And also, the strategy I'm going to use is particular to what I've been teaching in class. So if you have something new and wish to show your students, that's fine. Or if you have a cooler way to do it, that's also fine. I'm going to start from the left and work to the right. I know sometimes people have said, well, it doesn't matter which side you're working on, but I find that the way that the book and my tests structure the problems, you're given the most information on the left, and the right is going to be the more simplified version of it all. This problem it could be debated of which side is better to start with, but we're going to start with the left-hand side. And my strategy is going to be to turn everything into sine and cosine and just see what I can see. So now I have 1 plus, and tangent is going to be sine theta. This is because of the trigonometric identity that tangent is equal to sine theta divided by cosine theta, or y over x if you are using the unit circle. And then I'm going to turn this into sine and cosine as well. Okay, just put that little dot there. Come on, buddy. Okay. So now what I see is that maybe if I get a common denominator, I can maybe combine the numerators into something. So I'm going to multiply this 1 by 1. But this 1 is really going to be cosine over cosine, and that's to get my common denominator, so I can then put the 1 plus the sine theta over cosine theta together. I'm going to multiply this by 1 as well, and I can do that because you can always multiply by 1, but this fancy looking rectangular 1 is cosine over cosine. What this gives me is that this gives me cosine theta over cosine theta plus sine theta over cosine theta. And I just combined my denominator, because I would have cosine theta over cosine plus sine theta over cosine. Now I can just make a common denominator here. And I'll do the same thing down here. This is going to be a cosine theta minus sine theta. There we go. All divided by cosine theta. Okay, so here we have our beautiful mixed fraction now, where we have a fraction over a fraction. I think I said mixed. I really meant to say complex fraction. Complex fractions have fractions over fractions. So dividing fractions, please don't cry. Skip, flip, and multiply. So we're going to skip the first fraction in the numerator and write that down. Cosine theta plus sine theta, all divided by cosine theta. And then I'm going to multiply that by this fraction flipped on its head. Because again, skip, flip, and multiply means that if we have this a over b divided by c over d, then I can just take a over b and multiply it by d over c. I'll show you that. So a divided by b, if that's divided by c divided by d, this is equivalent, that should be a d there. This is equivalent to a over b times d over c. So again, skip, flip, and multiply. So now what we have here is cosine theta, and in our denominator we have cosine theta minus sine of theta. Now we have a multiplication of two fractions, and this is something called cross simplification. Most of us call it cross canceling because this and this divide to make 1. And now what we have left is cosine theta plus sine of theta divided by cosine of theta minus sine of theta. So let's go back to our original three strategies. Our first strategy was turn everything into sine and cosine, which we've done. The second strategy is to try to get a monoculture of terms, but unfortunately with sine and cosine, and these are not squared trigonometric identities, there's no way to do any conversions. So I should probably seek guidance from the answer. So my answer is cotangent theta plus 1 and cotangent theta minus 1. Now look at what we have so far. What we have so far is we have something plus something, so that numerator looks pretty close, and something minus something. Now that denominator looks pretty close. I wonder if there's a way to get the numerator to be cotangent plus 1 if I have sine plus cosine plus sine. And there is. I can multiply this whole thing by a very fancy looking 1. Now, one way to do it that maybe not be so obvious is to multiply the top and bottom by secant. Let me think if I said that right. Nope, cosecant, excuse me. Multiply the top and bottom by cosecant. What that would do is cause a lot of cancellation. But instead of me writing down multiplying the top and bottom by cosecant, I'm going to multiply the top and bottom by something that cosecant is equivalent to, which is 1 over sine. Cosecant is equivalent to 1 over sine. So by multiplying the top and bottom by 1 over sine, which again is the same thing as multiplying top and bottom by secant, you get some cool simplifications. For example, cosine theta times 1 over sine is equal to cotangent theta. And I'm getting pretty happy because I'm looking at my desired result and it's pretty close. Then sine of theta times 1 over sine theta, that is going to be 1. All right, so far so good. I'm probably going to finish this off here because I've got cosine theta times 1 over sine theta, which is cotangent theta. And the sine theta times 1 over sine theta is going to be minus 1. Well, there we go. That is actually our answer. And so instead of an arrow, I can choose to put an equal sign, and we're done with the problem. We have showed in this way, again, there's more than one ways to do the problem, that 1 plus tangent theta divided by 1 minus tangent theta is equivalent to cotangent theta plus 1 and cotangent theta minus 1. Okay, so on to the next problem. Okay, change colors here. The next problem. Let me check to make sure I'm writing this down correctly. Okay, so here's what we got. Secant, let's put this as example 2. All right, I can erase that because we have the technology. Okay, example 2. Secant theta divided by cosecant theta plus sine theta divided by cosine theta, let's see what that looks like, right, is equal to 2 tangent theta. Okay, well, I see how our first strategy is to turn everything into sine or cosine, and we could definitely do that over here, but maybe the best strategy would be to seek out some guidance from the answer. The answer is 2 tangent theta, so we're trying to get everything probably in terms of tangent. And I can notice that this right here literally is tangent, so I'm going to say this is tangent theta. Now how about secant over cosecant? Well, maybe that's too confusing right now, so maybe let's split this up as secant theta times 1 over cosecant theta. Okay, so let's do some conversions into sine and cosine. Secant is the same thing as 1 over cosine. That's the reciprocal function. Cosecant is equivalent to 1 over sine. Now off to the side here, here's what I have. 1 over sine. So again, we're going to use what we learned in the last problem about mixed fractions, where we're going to skip the first fraction, flip the second fraction, and multiply. So 1 divided by cosecant theta, which is the same as 1 over 1 divided by sine of theta, is the same thing as sine of theta. Another way to think of it is think of the fact that this is the reciprocal of 1 over sine. And flipping 1 over sine on its head, like we do with reciprocals, would just make it into sine theta over 1. And we wouldn't write the 1 in our final answer, but sometimes we put it there just for ease of use. So now I have 1 over cosine times sine theta over cosine theta. Well, that's just going to be sine theta over cosine theta plus tangent of theta. And then we can kind of think to ourselves, oh my gosh, look at this. Sine theta over cosine theta is tangent of theta, and tangent of theta plus tangent of theta is 2 tangent of theta. All right, there's example 2. Lot shorter than the first one, wasn't it? But it was shorter because we had used a lot of the things that we did in the previous problem to help us with that. Okay, on to example 3. Let's move past the page break. Okay. Example number 3. Okay. So here's what I have. Just making sure I'm writing down the problem, right? Okay, so I've got sine theta divided by sine theta minus cosine theta, and that's equal to 1 over 1 minus cotangent theta. So, my first strategy of turning everything into sine or cosine is not going to work because, well, everything's sine or cosine already. So what must I do? Looks like I'm going to try to seek guidance from this right-hand side. Now, like I did in the first problem, look at my numerator. My numerator is sine. This numerator is 1. This denominator is sine minus cosine. This denominator is 1 minus cotangent. What if I take, see, if I look at this left side and the right side, it looks like I have the same pattern, except instead of 1, 1 cotangent, I got sine, sine, cosine. Is there a way I can maybe turn the sine into a 1? There is. I could take the numerator and multiply by, I could actually not just take the numerator, but I could take this entire fraction and multiply the top and bottom by the same thing, which is essentially multiplying by 1. Now, one way you can think of it is I'm going to multiply everything by cosecant. And by multiplying everything by cosecant, cosecant times sine is going to make a 1. secant times sine is going to make a 1, and cosine times cosecant is going to make cotangent. But that might be too fast for some of you to see. So let's erase this idea first. There we go, get rid of that and that and that. And let's show, instead of multiplying by cosecant, we're going to multiply the top and bottom by 1 over sine, which is the same thing as multiplying by cosecant. If you're watching this video, you're seeing that there's a lot of repetition in the stuff I say, and I sometimes try to do things a little differently, just to show you different perspectives, but you're going to get to the same answer. So sine times 1 over sine is 1, and sine times 1 over sine, because this is going to be some distribution here, is going to be 1, and then the minus cosine over sine is happily what we need for this problem, because what we have is now 1 over 1 minus cotangent theta. All right, and that is that answer right there. For example 4, I want to see tangent theta minus cotangent theta divided by tangent theta plus cotangent theta and have it equal to sine squared theta minus cosine squared theta. Now, sine squared theta minus cosine squared theta is not equal to 1. It's easy for beginning trigonometry students to say, oh, this is equal to 1, but it is not. You're getting that confused with sine squared theta plus cosine squared theta. That's equal to 1. So there's no way you can do any kind of good conversion on this side. So let's start with the left-hand side, and let's kind of talk about what are our strategies. Well, looks like we should probably turn everything into sine and cosine. So here I'm going to take this into sine theta divided by cosine theta minus, cosine theta divided by sine of theta, all divided by, this is our denominator of tangent theta plus cotangent theta, so this is going to be sine theta divided by cosine theta plus cosine theta divided by sine of theta. Okay, so what I need to do, and since I have this complex fraction, is I want to see if I can combine these two fractions together. And I need to get common denominators. So I'm going to multiply this side by 1, and I'm going to multiply it by sine over sine. And the reason why I'm going sine over sine is because this denominator has a sine in it, this denominator has a cosine in it. So if I multiply it by the fraction by the other denominator, what I get is I will get a common denominator. Now I should have my thetas here after the sine and cosine, but just in terms of speed, I'm just going to omit those. So what that gives me is, it gives me in my numerator, it gives me sine squared theta. So you can see that sine times sine is sine squared, minus cosine squared theta. This is actually kind of cool because now you can see my answer here. Like, wow, I wish I could just stop, but I can't. I have to find a way for the entire thing to simplify. And now I have in my denominator, I have cosine theta sine theta. This is my common denominator, because here I would have sine squared over cosine sine, minus cosine squared over cosine sine. So I just combine denominators. Okay. Now here, I'm going to multiply by sine over sine. And again, the reason for doing that is because I want to get a common denominator here. And I'm going to multiply this by cosine. Okay, so let's go and do that. So now my denominator of my complex fraction is going to be sine squared theta plus, cosine squared theta, all divided by cosine theta plus sine theta. All right, now a couple cool things are going to happen, because if we now process this complex fraction, if we process this complex fraction, we'll have skipping the first fraction, flipping the second fraction, and then multiplying. So in my numerator, I have sine squared theta minus cosine squared theta divided by cosine theta sine theta. And now I'm going to multiply that by the flip of this, which is going to be cosine theta sine theta divided by sine squared theta plus cosine squared theta, which is 1. That is our first note card that I ever gave to you in trigonometry class, if you had my class face-to-face. But this is also the main Pythagorean identity. So we have some simplification here, because this simplifies with that to make 1 over 1. So this times 1 divided by this times 1 is equal to what we were looking for in the problem, which is sine squared theta minus cosine squared theta. All right, there's 4 problems for us. We'll have another video with 4 more, even more challenging problems. And thank you very much for watching.